A very important part of any college algebra, precalculus, even calculus class that you might be taking is to be able to find the x and y-intercepts of a function. This is very important when you're trying to figure out what a function looks like on a graph. And so you're definitely going to want to be familiar with what process you need to go through to figure this information out for any function that you're given. In this video, I'm going to be showing you exactly how to do that, how to set these problems up, and the exact steps that you're going to want to go through to get to the final solution of your x and y-intercept of a given function. If that sounds good to you, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump right into it. Find the x and y-intercepts of the graph of the equation y equals square root of 2x minus 1. So there's a couple ways to do a problem like this. The first one would be to graph your function and look at your picture and see where it intersects with each of the x and y axis. You can also do this algebraically without having to deal with graphing. Personally, I think graphing probably adds extra steps that you don't necessarily need to deal with. And doing it algebraically is going to be more likely to get you the exact correct answer anyway. Instead of using a graph that you sketched, you're really just getting yourself an estimate. Doing it algebraically is going to get you the exact number that you want to get to. So that's probably the better way to do it. So I'll show you how to do it that way. Really, when it comes to finding x and y intercepts, what you want to do is think about, just very, very quickly thinking about what a graph looks like. If we have an x and a y axis, thinking about, let's just say we have some function like this, okay? If we're thinking about our x and y intercepts, looking at the points that intersect with x, the places where your function intersects with x, what do you know about the y coordinate at those points? Well, the y coordinate is 0. They all happen at y equals 0. So to find x-intercepts, you want to look at the places where y equals 0. Okay? And then similarly, if we're trying to find the y-intercepts, the places where our function intersects with the y-axis, we want to look at where x equals 0. That's where the x-coordinate of our function is 0. So to find y-intercepts, you look at where x equals 0. So it's basically opposite. X-intercepts where y equals 0, y-intercepts where x equals 0. They just kind of go back and forth. So I just kind of drew this for the sake of talking about x and y-intercepts and what they mean. This is not what this equation looks like. That is not the correct graphing of that equation. I just quickly wanted to demonstrate what I meant by x and y-intercepts with a random function graphed over there. So getting back to this actual equation. To algebraically figure out where you have your x-intercepts, that is just where y equals 0. So if we go to our equation and replace the y with 0, so if y equals the square root of 2x minus 1, if we replace y with 0, that just gives us 0 equals the square root of 2x minus 1. Now, if we solve this equation for x, that should tell us where all of our x-intercepts are. And then similarly, if we go to our equation and we replace our x's with 0 and then solve for y, that should tell us where our y-intercepts are. So if we go to this equation, replace all of our x's with 0, in this case we just have one x right here, replace it with 0, we get y equals the square root of 2 times 0 minus 1. And then if we solve that equation for y, that should tell us our y-intercept. So basically we can kind of break this down into these two equations that we need to solve for either x or y to find our x or y intercepts. So let's start with this first one here. 0 equals the square root of 2x minus 1. We want to solve for x. So we're just trying to get the x all by itself. So we just want to kind of start thinking about how to start moving stuff over to the other side of the equation. To do this, what I like to do is think about order of operations, PEMDAS, parenthesis, exponent, multiplication, division, addition, subtraction. When you're trying to solve for something on one side of the equation that has all these other operations happening to it, we're trying to solve for x. You can see here we have a square root going on, we're multiplying it by 2, we're subtracting 1. We have all these other operations happening to our x. Like if we were to plug in an x value here, we would have to do all these different operations to solve for this whole side of our equation. PEMDAS tells us the order that we would apply those operations. So we would first deal with what's inside the parenthesis or inside the square root. It behaves kind of the same. Within that, we would have to do the multiplication first and then the subtraction second. Well, the reason I bring up PEMDAS and the reason I bring all this up is because if we're trying to move all this stuff to the other side of the equation and get our x all by itself, we're going to do them in we're going to kind of move them over in the opposite order that we would do those operations to x. So if you imagine plugging in some value for x, the first thing you would do is multiply it by 2. So that's going to be the last operation we move over to the other side of the equation to solve for x. Okay, so first we would multiply by 2, then we would subtract 1, then we would square root it. So this is kind of the order we would go in. Times 2 minus 1, then square root. So we need to move these three things over to the left side of the equation in the opposite order. So we need to deal with the square root first. So dealing with the square root basically means we want to figure out what operation cancels the square root. Well, that would be squaring it, right? So if we square both sides of our equation, that'll cancel the square root on the right side and basically move it over to the other side. So 0 squared is just 0. So 0 squared is 0. The square root is now canceled, so we just have 2x minus 1 on the right side of our equation. Okay, so we dealt with the square root now. Now we need to deal with the minus 1. The opposite of minus 1 is plus 1. So if we add 1 to both sides of our equation, that'll cancel the minus 1 on the right side. 0 plus 1 over on the left side of our equation is 1. Since we canceled the minus 1 over here, we just have 2 times x. So we've dealt with the subtraction of 1. Now the last thing we need to deal with is the multiplying by 2. Well, the opposite of multiplying by 2 is dividing by 2. So if we divide both sides of our equation by 2, it'll cancel the 2 there, and we will just have x equals 1/2. So x equals 1/2 should be our x-intercept of this equation. Okay. Now we need to find our y-intercept by dealing with this equation here. So we have y equals the square root of 2 times 0 minus 1. So in this case, we already have the thing we're trying to solve for isolated. It's already by itself on one side of the equation. So what that means is to solve for this, we would actually just follow PEMDAS in the correct order. Parenthesis, exponent, multiplication, division, addition, subtraction. Because what we've done here is we've actually plugged in a 0 for x. So over here, I kept saying, if we were to plug in a number for x, what order would we deal with these different operations? Well, over here, that's exactly what we've done. We've just plugged in a number for x. We've plugged in 0 for x. So we would go in that same order. First, we deal with what's inside the square root, what's inside the parentheses, basically. Inside of there, the first thing that we have to do is multiplication. So 2 times 0 is our multiplication. 2 times 0 is 0. So we're going to have 0 minus 1 within our square root. Then we would deal with addition and subtraction. In this case, we have subtraction. So we have the square root of 0 minus 1, which is negative 1. From there, we're trying to take the square root of negative 1. Well, you can't take the square root of a negative number. So this actually does not exist. So what that means is there are no y-intercepts of this equation. And if we were to graph it, we would find that out, basically. You'd be able to see it graphically and visually, but also doing it algebraically this way confirms that the only value for y when x equals 0 is one that does not exist. You can't take the square root of a negative. So no y-intercept. We only have the x-intercept of 1/2, and that is all of our x and y-intercepts of this equation. Knowing how to find the x and y-intercepts of a function is very important, but what if you need to figure out what other points lie on the function? Obviously, the x and y-intercepts is only a couple of specific points that your function crosses through. Well, I've made a video showing you how to figure out what points lie on a function based on other x values that you might be interested in, just go click on that video over there. That's going to be an important thing that you're going to want to nail down after understanding how to find x and y intercepts of a function. So just go click that, and that should help you with that.